Okay, hello everyone, it's Salar and we are in part 52 of our tutorial, a tutorial to writing a real-time operating system. In previous part, I described the structural wait list, okay? And I said, in previous part, I said in this part, I want to implement, thread wait to make a delay by using of this system call. So in this part I want to implement waitList for the Rtos. In the repository of the project under commit 11, okay, I've updated my project and I implement waitList for the Rtos and add implementation of thread wait to the Rtos implementation of this system call. And by using of this system call, I can make a delay running up a thread. Okay, but let's implement the waitList. As I said, here is the structural waitList, and I want to implement this structure and use that to make a delay. And number of waitlist is 8. Number of waitlist has been defined here. Include Rtos type definitions. Number of waitlist, okay, is 8. Defined. You can change its value in this file. Okay, so to implement a new data structure waitList, I need to define some function for this new data structure in list.h and list.c. I said all of data structure defined in these files and will be defined in this file. So I need to implement data structure manipulation functions in list.h and list.c. As you can see in list.h, I've defined some new functions to manipulate waitList. For example, create new node, like create new node for waitList. At this time for waitList, create new waitList. You can see waitList is a simple queue. Create new queue, simple queue. Okay. Wait node is a queue node, and waitList is a queue, simple queue. Okay. A function to insert a thread to waitList by using a waitList number. Okay. Insert to one of these queues. Okay. Delete from waitList by using a waitList number. Get first thread in a waitList in one of queues. Get next, get total size up all of these queues. Okay. Get size up one of queues and check if a queue is empty or not by using another time by using a waitList number. Okay, and all of functions implemented in list.c, and implementation is straightforward. You can read these functions by yourself and comprehend them. Okay, so first you must define manipulations functions for waitList in list.h and list.c. After that, to implement waitList in Rtos type definitions.h in this file, you must add waitList to the kernel control block like ready list. kernel control block. After ready list, I have a wait list. Like ready list is array of pointer to some other data structures, in this part to some queues. Wait list is this array. Okay, this array is wait list, and each element of this array point to a queue. The size of array is number of wait lists. And after that, add another member to the kernel control block, waitlist handler request, like system call request and context switch request. After context switch request, I have waitlist handler request, like system call handler request and context switch request. Okay. After that, in kernel.h, you must define this function kernel waitlist initialize and call this function in kernel initialize. Okay, you must define and implement kernel waitlist initialize. Let's see at this time here in Rtos source and kernel. Kernel waitlist initialize. You must define and implement this function and create the waitlist like here, according to the number of waitlist. For each number, create a queue, a simple queue. Okay, here. And you must call this function here after readylist initialize. You must do waitlist initialize in kernel initialize. Okay, to initialize the waitlist. After that, when you want to insert a thread to the waitlist, you must have a wait node for each thread. When you want to insert a thread in a queue, you need the thread needs to have a wait node, a queue node. Okay, so add wait node and return tick. I said return tick is current tick plus desired delay. You must save this value for each thread. Okay, so you must add these two members in thread control block. Wait node is a queue node and return tick. Wait node and return tick. And after that, like initialization in kernel, you must initialize this wait node when you create a new thread. Okay, in thread create new system call, kernel space system call. Here is thread create new system call. After initialization ready node, you must initialize wait node and create a node for each thread and put this address of this node at this member, thread control block wait node, and you must set value of return tick to 0 when you create a new thread. Okay, now at this moment waitlist structure created. But now let's talk about thread wait. I said by using of the system call in thread you can make a delay. Let's see implementation of thread wait. Thread wait is here. Let's see at the bottom of this file. Thread wait defined here. By using of this user space system call, the system call, you can you can make a delay for a thread. Here is number of ticks and is number of milliseconds, because each tick is 1 millisecond. Each tick is 1 millisecond in the Rtos, in our Rtos, okay? So, for example, when you call thread wait, for example, thread ID 1 and 500 millisecond. You stop running a thread 1 for 500 milliseconds. Make a delay in running a thread 1. Okay? But let's inspect the implementation of this function. You can't call this system call from interrupt. Okay? But like other system calls, put arguments in a specific data structure. Put address of this data structure in addition of system call number in global struct and call kernel system call. Okay, like other system calls. And after that, let's inspect kernel space system call. According to the number of ticks, the desired delay, number of ticks, and current tick. You can get the current tick by using this function kernel get tick to get the current tick. You can calculate the return tick, current tick plus number of tick plus delay, and by using this modulation operator, you can acquire the wait list. Return tick modulated by number of list is wait list number of one of these queues. Okay, and Rtos must insert the thread in that queue. Okay, after that write return tick in thread control block in this member. After that, if thread is running already, delete thread from ready list. Okay, to make a delay you must delete thread from ready list. After that, by using a wait list number and thread ID, insert thread to one of wait list and change the state of thread to waited. Okay, it's a new state. It's a new state. When you have a thread in wait list, the state of thread is wait. And after deleting a thread from ready list, you must check for context switch. Study body of this function by yourself. If context switch is necessary, request for context switch. Okay, so find wait list number, delete thread from ready list, and insert it to wait list. Okay, now delay started. So by using a thread wait, you can make a delay for a thread. Now to return a thread from waitlist after finishing delay. I said you must, and Rtos must check waitlist structure by each systematic exception. Each 1 millisecond, Rtos must check waitlist. Okay, but how Rtos does this work? How does Rtos do this work? By using up kernel waitList handler, by using up this function. But I said by each systematic exception you must check waitlist. You must call this function by each systematic exception. And I said you must, the Rtos must do all of its works, its jobs in SVC. But from systematic, you can't directly call SVC because systematic has higher interrupt priority than SVC, and from a higher priority exception you can't call SVC. So after requesting for waitlist handler, after requesting request a check for waitlist handler, first systematic must call pendsv, and pendsv can call SVC. Okay, and to register a request you like context switch and system call handler, you must implement this function. Okay, this function set a member, set this member in kernel control block, and after that call pendsv. Okay, this function like request for context switch and request for system call. And by using of this function you can set unset and get the value of another time this member. Okay, but let's run an example and inspect the waitlist handler structure, waitlist handler function. Okay, I have an example. In this example I have 3 threads, thread 1, thread 2, thread 1 and thread 2 priority is normal, and thread 3 with priority high. Okay, if I put some breakpoints here because thread 3 has higher priority, operating system jump to thread 3 functions. Okay, but if I run thread wait by using of these arguments, thread ID 3 and 500 milliseconds and 500 milliseconds. Okay, Rtos put thread 3 and insert it to the wait list, and after that jump to thread function 1. Okay, because thread function 3 inserted to wait list. Okay, and if I delete this breakpoint another time, run the codes, after 500 milliseconds Rtos return to thread function 3. In the kernel.c you can see now the tick is 500. Okay, now the tick is 500. But let's inspect kernel waitlist handler. Reset the code. Delete this breakpoint. Go to the this assembly file and put a breakpoint here in system tick handler. If I run the code now, I'm in system tick handler. In system tick handler, in each millisecond, Rtos must request for waitlist handler. Okay, so let's inspect waitlist handler. In this function, first set a variable in kernel control block. After that, request for pendSv. Okay, request for pendSv. But because systemtick has higher priority than pendSv, processor doesn't jump to pendSv handler. But after returning from systemtick, processor jump to pendSv handler. Now, first check for context switch. Okay, because there is a context switch request here. If I run this code, the value of R0 is 1. Okay, the value of R0 is 1. So first check for context switch. Let's do run check for context switch. Oh, there are a lot of lag in running of this code in my laptop. Sorry, but after context switch, check for waitlist handler, and another time R0 is 1. Okay, is 1 because we have a request for handling the waitlist and check the waitlist. But let's check the waitlist. Jump to this label and in the pendSv request for SVC. Okay, request for SVC. And another time in SVC check for waitlist handler. We don't have request for system call, so it doesn't jump to this label, but we have a request for waitlist handler, so Rtos jump to this label and call kernel waitlist handler. Call kernel waitlist handler to check the waitlist. But how does the operating system, the Rtos, check the waitlist? I said by each systemtic exception, Rtos must check waitlist to see is there any thread with runout delay. Now, Rtos wanted to find a thread with runout delay, with finished delay. do this work. Kernel waitlist handler do this work. Search the entire list. Which list? For example, when current tick is 500, check this list. Check list 4. Entire of this list. The queue that's related to this current tick. Okay? Check if return tick of a thread in this list. For example, assume in list number for another time you have, in this queue you have 2 threads, one with 500 in return tick, another with 900 in return tick. Check if return tick of a thread equals to current tick, delete thread from waitList and insert it to RtoS. So check entire of this list. So let's jump to kernel waitList handler. First, get current tick, and by using a current tick, acquire waitList number, and get the size of this list, waitList number. Okay, and run this part. If the size greater than 0, get first. For example, get first node in the list. Okay, and for each node, and check all of the nodes in the list from 0 to the list size. Each a return tick of a thread in this list equals to current tick, delete from waitList and insert it to RtoS. Okay, another time, search the entire list, one of the queues. Okay, check if return tick of a thread equal to current tick. Check if return tick a thread equals to current tick. Delete thread from waitList and insert it to RtoS. Delete thread from waitList and insert it to RtoS. Okay, very good. In this way you can make a delay. You can put a thread for a specified time in the waitList and return that thread to the RtoS after elapsing the delay. Okay, now another time, reset the code. Now if I run this code, I will have this string each 500 milliseconds in the output. Okay, let's remove all of breakpoints and run and open Qt. Clear the screen and run the code. Now each 500 milliseconds I have this string in output. So by using a thread wait, I can make a delay. Okay, very good. This was the implementation of waitList and implementation waitThread. thread waits, thread wait in the Rtos, and by using a thread wait you can make a delay in your code by using a wait list and this system call. You can make a delay, and by each systematic exception interrupt you must check wait list by using of this function. Okay, very good and very nice. Thank you very much to see me, and see you soon in the next part. Thank you very much.